Hello everybody, and welcome to the notes on simplifying radicals in exact form. What you're going to need first before I get into what this skill is I would like you to please pause the video and copy down this list of perfect squares. So please copy down all in the blue, like 1 squared, 2 squared, 3 squared, and please also copy down these lists here in red. These are the numbers here that are the important ones for this video. So please pause now and copy these down. Okay, now that you've copied these down, the goal of simplifying radicals is a sub-skill from where we're heading in Chapter 9. Our goal for Chapter 9 is to keep solving quadratics, but other ways other than just factoring. And so what we need to do is start recognizing the square root notation. And what square root means is what number times itself. So this really very much has to do with perfect squares, which is what we've done with factoring already. But for instance, if I asked you what the square root of 100 was down here, that would be what number times itself gives you 100. Well, 10 times 10 does. So the answer to number 1 would be 10. If I asked you what times what is 36, that would be 6. So my answer for number 2 is just plain old 6 because it's a perfect square. Number 3, what number times itself gives you 16? That's 4. And number 4, what number times itself gives you 64? That would be 8. So when you see the square root symbol, ask yourself what number times itself makes this number under here true. And if you do have a perfect square, you completely can take the radical off of the number. So I'm going to write that down too. If you have a perfect square, you can take the radical off the number. Or even to be more specific, you can take the radical off the final answer. So all of this is going to lead to something like number 5. If I have the square root of 175, if I look back at my list, I go directly from 169 as a perfect square to 196. So 175 is somewhere in the middle of them, so it is not a perfect square. So what do we do if we don't want to have this as a decimal, and we would like this in something called exact form? Please make sure that when you're doing these notes, you have these perfect squares in mind the whole time, these red numbers. What your goal is to take 175 and not plug it directly in the calculator, but instead to split this number into one radical, which would be a perfect square, and the other radical that is not a perfect square. So what we need to do is think about all the numbers that multiply to be 175. Now, the caveat is that I would only divide 175 by your perfect squares. So if we look at the list of perfect squares, I know for sure that 25 would go into 175 because it ends in a 5. So why don't I try that? 25 times 7 is 175. So what I can do here is put 25 in the first radical, because it's a perfect square, times 7 in the second radical. So what we're saying is that root 25 times root 7 is root 75, which is true. So what I do from here is look at my two radicals and say, which one of these is my perfect square? Well, this one is. So my answer would be, what number times itself gives you 25? Just 5. And because it's a perfect square, I can take the radical off. However, if you look back at the list, I don't have a number times itself that's 7. We go from 4 to 9. So because 7 is not a perfect square, we leave it in the radical. And so this is root 175 simplified in exact form. We split into perfect square and not. If I look at number 6, let me think of all the numbers that multiply to be 216, and specifically focus on the perfect squares, 1, 4, 9, 16, 25. So if I think about the numbers that multiply to be 216 as a perfect square, I know that 4 times 54 is 216. If I try 16, because I notice that 216 is an even number, so I'm going to divide by the even perfect squares. Let me divide by 16 and see if that works. Let me go back to this. If I take 216 and I divide that by 16, I get 13.5. So that doesn't work. So the next even perfect square is 36. If I take 216 divided by 36, I get 36 times 6 is 216. And for good measure, I'll take 216 divided by 64. That doesn't work evenly though. So these are my options. My suggestion to you would be always pick the pair that has the largest perfect square. This will work, but it'll cause more work for you. So what you would do is take 216 and split that into a multiplication fact, 36 times 6. Because 36 is my perfect square, I'm able to take the radical off of 36, and 6 times 6 is 36. However, there is no number times itself that is 6. If we look back, we go directly from 4 to 9. So my answer for number 6, interestingly enough, is 6 root 6. Not planned there. Number 7, 112. What I'm going to do is figure out what perfect squares multiply in there to be 112. So because it's even, I'm going to try 4 first. If I take 112 divided by 4, I will get 4 times 28. 28 is still a pretty big number, so let me see if there's a bigger perfect square. Let me try the next even one. 112 divided by 16. 16 times 7. Awesome. What if I did 112 divided by 36? That doesn't work. 112 divided by 64. That doesn't work. Let me see. 112 divided by 64. Nope. So if I look at my pairs, this one has the larger perfect square. So I'm going to take my 112, split it into the multiplication fact of 16 times 7. My perfect square always goes first. So the square root of 16 is just 4. But 7, there is no number times itself that's 7. So my answer is 4 root 7. And again, this skill will really, really help you as we keep going through Unit 9. So it's good to focus on this first. Number 8. If I try to multiply to be 128, again, I'm kind of sticking with evens to start. I'm going to try the even perfect squares. So I'll take 128 divided by 4 first, and I get 4 times 32. I'm going to try 128 divided by 9 just because. No, that doesn't work. 128 divided by 16. 16 times 8. These are still, maybe I can keep splitting them, and I'll talk about that. So let me see what else I can find. 128 divided by 36. No. 128 divided by 64. Yes. 64 times 2 is 128. So I'm going to pick the pair that has the biggest perfect square. I'm going to split that into 64 times 2 is 128. The square root of 64 is 8. Square root of 2 is just square root of 2 because there's no number times itself that gives you 2. So that would be my answer for number 8. Now let's say, I want to show you on this example, let's say that for number 8, you had picked 4 and 32 instead. Let's say you found this pair first and you said, I think it's 4 times root 32. This would work, but you just wouldn't be done as quickly because the square root of 4 would give you 2, but then you'd be left with root 32. But then you would have to recognize that 32 could be split again because I know that 16 times 2 is 32, and 16 is a perfect square. So then you would have 2 times 4 root 2, and 2 times 4 would get you 8 root 2. So you would get the same answer, but in the end it would be a slower process. So my goal again for you is to always look for the largest perfect square. These next examples, I would like you to pause, and I would like you to try on your own. So I would like you to take all of these numbers, see what's the biggest perfect square that divides in, and split each radical into 2. So please pause the video now, and when you come back, I will have my work. Please pause now. So guys, I'm back with my answers. Number 9, I split into the perfect square 9 times 3, and the square root of 9 was 3, so I said 3 root 3 was my answer. Number 10, I want to specifically focus on. 72 is a very common pair to pick. I had 3 options. The perfect square of 4 times 18, perfect square 9 times 8, and perfect square 36 times 2. I picked my largest one because I wanted to create less work for myself. Now, I'm guessing that some of you may have picked 9 and 8. And it looks like it might be done because the square root of 9 is 3, root 8. However, the square root of 8 can be split again because 8 is 4 times 2. So if you did 3 and split this to be root 4, root 2, you'd have 3 times 2 root 2 or 6 root 2. So your answer would be the same. So please be careful about root 72. It comes up quite a bit. Number 11, the only perfect square pair I got was 9 times 6. And 6, there is no number times itself. So my answer was 3 root 6. And then number 12, the only perfect square pair I got was 4 times 7. Square root of 4 was 2. So 2 root 7 was my answer. The last part of these notes here is to preview things again that are coming. And so I want to do the order of operations for number 14. Then I want you to try 15. So 14, we have a very giant square root, but we want to focus underneath the square root first with the order of ops. If we're thinking PEMDAS, we want to do parentheses, which is pretty much this big radical, and then exponents second. So if I did negative 4 squared, or negative 4 times itself, that would be 16 minus. I always want to multiply before I subtract. So 4 times 3, if I do 4 times 3 times negative 6, that would get me a 72 or a negative 72. So because I have two negatives though, here and here, that would become a plus under the square root. So I have the square root. Let's keep going under the symbol first. 16 plus 72 would give me 88. And now this skill works with what we were just working on. So I can take root 88 and I can split that into perfect square and not. If I think about 88, I know 4 times 22 is 88, and 4 is a perfect square. If I look at 22, I don't think there's anything else I can take out of that. So I'd have 4 times 22. So my answer would be 2 root 22 for number 14. So what I'd like you to do is pause, and please try 15 based off what I did on 14. And I'll come back with my work. So please pause now. Okay, so the first thing I did was I squared negative 5, and I got positive 25. I kept my negative. I then multiplied 3 times 2 times negative 8, because multiplication comes before subtraction. I got 48 for that, but then I had a double negative. So that double negative here became a positive. I added 25 and 48 and got 73 under my square root. I looked at my perfect square possibilities here, and I didn't find anything that divided into 73. So what I would do is keep my answer as a radical, because I can't split it. So my answer would be root 73. Last piece here, number 16 and 17, again, also a preview of what's to come. What we want to do for 16 is simplify this completely. Now, what I want you to realize is that root 40 is not a like term with the numbers without square roots. So I can't take anything out of all three of these terms yet. However, if I look at root 40 and I split that into the skill we've been using, what perfect squares multiply to be 40? Well, I have 4 times 10. I think that might be it, because I think 16 doesn't go in and neither does 36. So I would write square root of 40 as 4 times 10, all over 6. I then would reduce root 4 to be 2. So I'd have 12 plus 2 root 10. No number times itself is 10 over 6. Then, if I wanted to simplify, I notice that I have this triangle of numbers here that I can take a greatest common factor of 2 out. So I can divide everything by 2. So my answer would be 6 plus 1 root 10 over 3. And I cannot divide the 10 by 2 because it's not a like term. So please try 17 with that in mind, and I'll come back with my work. Okay, guys, here's my final answer. I took 45 and split that into 9 times 5. I reduced 9 to be 3, And this was my answer.